if you use radians or degrees. If you found degrees easier, the problem with radians is they come out as all decimals. You'll never recognize it with a pi in it. So that's why I said if degrees was easier for you, then degrees are fine. These guys, if you think this out and you actually figure out what it's saying, it'll make more sense. I want the sine of an angle, a restricted angle, whose sine is 0.7. So there's my sine, right? They kind of cancel each other out. I want the cosine of a restricted angle whose cosine is negative 0.3. I just want the cosine. There it is. So it kind of cancels itself out. It doesn't work that way with the arc part in front, such as this one. Arc says I want a restricted angle. This is what it's asking me. That has a sine of 3 pi. So order of operations, I go to my parentheses, I find 3 pi. 1, 2, 3. Here's 3 pi. It's not a restricted angle, it's just a regular angle. I find its sine. Its sine is 0. So I replace this with a 0. Now I want a restricted angle whose sine is 0. Sine goes from here to here, restricted, 1 and 4. So which one of these is a 0? Right there. And it would kind of make sense that is clear across the opposite x, the pole. Restricted sine is 1 or 4. But this angle right here, sine of 3 pi, that could be anywhere. Once you say arc, or sine negative 1, then it's a restriction. Yes, same thing. Okay, same thing with this guy. I want a restricted angle for tangent. But I want its tangent to be whatever this thing is. So I first locate this, and I find its tangent. Its tangent is negative 1 over radical 3. Now it just so happens that my tangent, restricted, is also in quadrant 4. It just so happens to be there. So now all I have to do is name the angle from, what's my restricted domain for tangent? 1 and 4, but what's the domain go from? Negative 90 to positive 90. So I can't give it as this guy. I give it as negative pi over 6 or negative 30. My answer has to be in the restricted angle. Found the restricted angle whose tangent was the same as the tangent of angle 11 pi over 6. What you guys need to do is just follow order of operations. Go to the parentheses, do that first. Back out of the parentheses and see what they want to know next. Okay? Alright. This guy, I go to my parentheses. I say I have any angle. Sine of 5 pi over 2. This is 1 pi over 2, 2 pi, 3 pi, 4 pi, 5 pi over 2. The sine of this guy is 1. So I'm technically looking for this. A restricted sine angle whose sine is 1. I'm restricted from here to here. Yeah, it just so happens to be the same angle, right? But I have to rename it to be pi over 2. Because my sine can only go from negative 90 to positive 90. From negative pi over 2 to positive pi over 2. I can't name my angle to be 5 pi over 2. It's out of my domain. Good? Okay, next one, parentheses first. Find the tangent of 5 pi over 4. If this is 4 pi over 4, then this is 5 pi over 4. 45 degrees. I want the tangent. The tangent is 1. Again, it comes back to this one. Find your restricted sine angle whose sine is 1. That's your pi over 2. You can cheat, put that in your calculator. And it kind of will give you your right answer. You know, of course, because it's doing a restricted angle. But it'll kind of lead you to where you need to be. Alright, these have the same concept, but they weren't your special triangles, and they weren't quadrantals. They're still different angles, and the thing is, we don't ask for the angle back, we usually ask for a function back. Otherwise, you have to pick up your calculator and find your angle rounding somewhere. So, I go to my parentheses first. It says you have a restricted tangent. It's positive, so it's in quadrant 1. Tangent is y over x. Find your r, so that now you can find me the sine of this thing. I have a restricted sine. I'm restricted positive in 1. Find me the cosine of this side. Okay? Stop me if you have any questions. I have a restricted tangent angle. A tangent of -3 over 5. Tangent is negative in 4, positive in 1. So I drop my triangle in 4. I find my missing side. And my secant is the reciprocal of cosine. My cosine is positive in quadrant 4. So my answer has to be a positive. Now, of course, if you put this one in on your calculator, you're not going to get that exact answer because this one has a radical. But you can reduce that radical and see if it's the same thing. 71, go to the parentheses first. A restricted cosine of negative. Well, cosine is restricted to 1 and 2. So the negative has to be in quadrant 2. You don't need to find the angle, you need to find the sine.
How do you know where to put the triangle?
Because where your restriction is based on this. Cosine, my cosine curve, goes like this. So my cosine, when I cut it off, this is the 90, this is the pi. My domain goes from 0 to pi. 0 to pi on my circle is here. 1 is positive, and 2 is negative. And when I find my angle, if I was looking for my angle, I would call this angle, well, this doesn't, it's not a special angle, but I would have to call it from here to here. Because my domain for cosine is from 0 to pi. Each one of them has 2 quadrants. Everybody's positive in quadrant 1. So the only thing you're really memorizing is tangent and sine are negative in 4. Cosine, negative in 2. So all you have to remember. No, because cosine is also negative in quadrant 3. So remember, we have to do a true inverse. So we can't use the entire cycle. Because in quadrant 3, over here where it is negative as well, it fails a horizontal line test. The idea of an inverse is a reflection over the y equals x line, but to be a true inverse, your function has to be a 1-to-1. In other words, it has to pass a vertical and a horizontal. If it doesn't pass a horizontal, we have to restrict it to make it pass a horizontal. That's the whole concept of an inverse. And if you remember back, we did inverses in your calculator, we did draw inverses, we restricted their quadratics to a increasing or a decreasing, and now we're doing it with your sine function and your cosine function. You have to get the restriction down. Yes?
So sine can use 1 and 4, cosine can use 1 and 2, and continuous.
1 and 4. Yeah. Now, this sine is just a regular sine for wherever this happened to land. That's not a restriction. Anything that says arc or sine negative will be a restricted. And that was it. Any questions? The first one says, what is it asking for? Arc sine. So I'm asking for an angle whose sine is restricted to whatever quadrant sine needs to be restricted to and has a sine of radical 3 over 2. What quadrant do I find this in? The first, everybody's positive in the first. So whenever you have a restricted angle and it's positive, it's got to be in the first quadrant. And again, label your pieces. Y over R. Special right triangle. But this time, I want to know what angle is this. So what reference angle is this? 60. And in radians, what would it be? Pi over 3. And I can absolutely put that into my calculator, can I? I would put it in degrees, not radians, because you're going to get a decimal. You're going to get 180 divided by, 3.14 divided by 3, like 1 point something or other. But I would put it in degrees, and then you can see your 60 degrees. Now the second one says, find me a restricted cosine angle, an inverse, that has a cosine of -1. So if I know my cosine goes from 0 to 180, and write all your restrictions on once at the top of your paper, then I know the zeros must be coming from the quadrants. The cosine is my x value. I look at my x values, and I say, oh yeah, there it is, at the pi, or 180 degrees. If I put it in my calculator, it will tell me 180. So can you like work yourself backwards and draw me this little sketch for 1 and 2 and draw me a little dot at 180? But just don't draw me the bottom part of the circle because it doesn't exist in the bottom. Only in 1 and 2. Okay. Try the next two. Try them while I write them down. Okay, where is my tangent restricted to? Which quadrants? 1 and 4. Where is it positive? 1. Tangent, y over x. What's my angle? 45. What's it in radians? Pi over 4. My cosine. Our cosine is the same as cosine -1. This is the inverse. Inverses are true inverses. They have to pass a vertical line test, so their original function has to pass a horizontal. Where is cosine restricted to? What quadrants? 1 and 2. It's got to be one of my quadrantal angles because it's a 0 or a 1. And where is it? 90. And doesn't that fall between, on my number line, between 0 and 180? Yeah. Got to fall between your restricted domain. Arc sine of 0, where is sine restricted to? 1 and 4, from here to here. And the 0 means it's falling up on one of these guys, on one of the quadrant angles. So for my quadrant angles, where's my 0? At the 0. Now, why could it not be 90? Why? Because it's 1, but this 0 and this 0 are in the same position. Could only be one angle in the restricted domain. So if I was a little bit saying, I don't remember which one it is, X or the Y, it can't be these two zeros. So it's got to be this guy. 0 degrees or 0 radians. And the last one, arctan of -1 over radical 3. Where's my tangent restricted? 1 and 4, and out of 1 and 4, where is it negative? 4. I drop a triangle. These wanted all the angles, all the arcs and sine -1s. Y over x. So what's my reference angle? Okay, my reference angle is 30, but my actual angle is -30. Because my domain goes from -90 to +90, but not including. So it's got to be the negative part in here. It can't come all the way around. It's not 330. It's got to be my -30. Does it make a little bit more sense?